All right, let's look at this example. A student goes to the library. Let event B be that the student checks out a book, and D, the student checks out a DVD. Suppose the probability of B happening is 0.4, and the probability of D happening is 0.3, and the probability of B and D happening is 0.2. All right. So we're going to find these probabilities. So part A says find the probability of B given that D happened. Right. So because I don't have sample spaces or like a contingency table here, we want to use a formula. So the formula for a conditional probability is the probability of B and D happening divided by the probability of D. So on the bottom is the probability of the condition, right? So let's see, do I have all these? I do. So this is 0.20, this is 0.30, so this simplifies to 2/3. All right, let's look at the next one. Probability of D given B. Now this is not the same as the probability of B given D. So this is going to be probability of B and D divided by the probability of B. It's divided by the probability of the condition. All right. So we have B and D is 0.20. Probability of B is 0.40, so this is 2/4 or 1/2. All right. Are B and D independent of each other? Okay, so if you remember kind of conditions for independence from previous things, right? One way of checking is that if the probability of B and D is equal to the probability of B times the probability of D, then they are independent. If they're not equal, then they are dependent. Okay, so let's check this out. So this is 0.2. This is 0.4 times 0.3. These are not equal because 0.2 is not equal 0.12. So not independent. All right, which means they're dependent. All right. Let's look at D. So D says, are these events mutually exclusive? Alright, so mutually exclusive means that they have nothing in common. There's no overlap. Alright, so sometimes you can decide this from the context. Sometimes you can decide based on calculations. If you do calculations, mutually exclusive, they are if you have the probability of A or B and D in this case is equal to the probability of B plus the probability of D. If they are mutually exclusive, it means the probability of B and D equals to 0. Okay, so we can see that this is not equal to 0, so there is overlap between the two events. All right, so this is not mutually exclusive. So it's mutually exclusive if. All right, so not independent, not mutually exclusive.